Okay, so in this video, I'm going to show you two different ways to use trig and what we know about right triangles when we have squares. Okay, so the first thing I'll do is I'll use Pythagorean theorem. The second thing I'll show you is trig. All right, so one example solved two different ways. We are starting off with this lovely pink square, and I want to know what is the measure of angle DAC. Okay, so we start DAC. So we're looking right here at this little angle. All right, what we know about squares, every single angle in a square is 90 degrees, right? Every angle is a right angle. And our diagonal right here is going to bisect our angles. And for something to be bisected, there it is one more time, we cut it in two equal pieces, right? So this 90-degree angle, we're breaking it up into two pieces that are going to be 45 degrees each. So this angle is going to be 45, same with this angle. So DAC is going to be 45 degrees. Same thing would be happening up here with these angles. All right, so now we're going to look. If AD, side AD, has a length of 10, that's right here, we know that all of these other sides also have a length of 10. That's one of the properties of squares, right? All sides are congruent. Our diagonal is not congruent, however, right? So let's find some missing sides. CB right there is going to be 10. DC right there is going to be 10. AB right here is going to be 10. Lastly, our diagonal AC. I'm going to show you two different ways. One is Pythag, right? Pythagorean theorem. We're going to use that. So I'm going to just redraw our triangle. So we really have two right triangles we can work with. I'm going to redraw that. Okay, we have A, C, B. We know that these sides are both 10. And this is our unknown, our little question mark. Okay, so we could use the Pythagorean theorem, right? We have 10 squared plus 10 squared equals our question mark squared. You could use x as well, whatever. All right, so I'm going to go ahead and put this into decimals because I am not doing that math in my head. 10 squared plus 10 squared gives me 200. Oops, you can't see what I wrote that down. The way we are going to get rid of squaring something, we have to do the opposite. So the opposite of squaring is square rooting. All right, so square root, you can type SQRT in decimals, or you could use a little keyboard and get it from right there. Okay, so that's going to give us 14.1 for our missing side. That diagonal AC is about 14.1. All right. Remember, if you ever have a decimal and you round, we got to use those squiggly lines, right? That's what it tells us. This is approximately, but not exactly 14.1 because we had to round because that decimal was gross. All right. The next way that you can do this, okay, our second way is with trig. Okay, so I'm going to redraw the triangle again, but we're going to be focusing on different parts of it, kind of. So what we know, like I said, this angle is a beautiful 45-degree angle. Okay, so now we know we're going to use trig to find this missing side. You can use whatever trig function you want as long as it involves this missing side. So I'm just going to go ahead and label. We know that this is our hypotenuse, this is opposite, and this is adjacent. Like I said, you can use whichever one you want. I typically use sine a lot, not for any really good reason. Like, that's just the one that I tend to gravitate towards. All right, so we're going to plug that in. So we have sine of 45 degrees equals opposite 10 over hypotenuse, which is our question mark, For this one, I'm gonna replace that with an x because it's about to get weird. How do we undo dividing by x? We are going to multiply both sides by x. Okay, so you have x times sine of 45 equals 10. And then how do I undo multiplying by sine of 45? I'm going to divide by sine of 45 on both sides. So this right here is exactly what you would type into Desmos and what I'm going to show you right here. 10 divided by sine of 45. So go to Desmos, delete, delete. 10 divided by sine 45. You can type it in on your keyboard, SIN, same thing for cosine and tangent, or click on your little keyboard, functions, trig, everything you're going to need is right there. Okay, that gives us 14.1 approximately. Okay, 14.1. Whew, shocker. Totally mind-blowing. Did not see that coming. They match. Okay, so like I said, you can use either way you want, whatever method speaks to you, whichever your heart desires. Okay, I'm happy with either. I personally think Pythagorean theorem might be a little easier, but this is just another way that we can use trig. All right.